Welcome to The Explainer. Today, we're pulling back the curtain on two fundamental concepts that power so much of the tech you use every day. We're talking about a super flexible way to store data and a really clever strategy for working with it. Put them together, and you can solve some seriously complex coding problems.
Right, so think about this for a second. How does Spotify handle that play next cue so smoothly? You can add a song, drag another to the top, delete one from the middle, and it all just works. Well, that's not magic. It's all about choosing the right way to organize that data. And as you're about to see, the most obvious way isn't always the best one.
To really appreciate our first concept, we've got to understand the problem it solves, and that story starts with the most common way we store a list of things, the good old array.
So picture an array like a big numbered row of parking spots. It's one single continuous block of memory. Now, this setup is fantastic for one thing, raw speed. Because every spot has a number, jumping straight to spot 10 or spot 100 is instantaneous. But, and this is a big but, that rigidity comes with a major downside.
What happens when you run out of spots? If the memory right next to your block is already taken, you can't just tack on more space. You have to find a whole new, larger block of memory somewhere else, and then copy everything over. It's like your parking lot is full and you have to move every single car to a bigger lot across town. Super inefficient, right? And that is the exact problem that our first concept, the linked list, was designed to solve.
Okay, so let's meet the flexible alternative, the singly linked list. I want you to stop thinking about a rigid box and start thinking about a dynamic chain.
See, instead of one giant continuous block, it's a series of individual links. The cool part is, each link can be stored anywhere in memory. Why? Because each one holds the exact address of the next link in the chain. This means we can grow or shrink the list whenever we want without all that shuffling. This flexibility, it's a total game changer.
And the magic is all inside this thing called a node. It's a really simple little package. It just does two things. One, it holds your piece of data, a song title or whatever. And two, this is the crucial part, it holds the memory address of the very next node in the chain. That's its only job. It doesn't need to know about anything else in the entire list.
And this quote just nails it. It really is like a treasure hunt. All we have to do is keep track of the starting point, which we call the head. From there, we just follow the clues, those next pointers, from one node to the next until we get to the end of the chain.
So this really gets to the heart of the trade-off. With an array, you get that awesome, super fast random access. You can say, give me the 50th item, and boom, you've got it instantly. But they're a pain to resize. Linked lists, on the other hand, are amazing at growing, shrinking, and reordering things on the fly. But if you want that 50th item, you've got to start at the beginning and walk through the first 49 to get there.
Okay, so now we have these awesome, flexible, chain-like structures. But that brings up a new question, doesn't it? How do we efficiently work with the data inside them, or really inside any kind of list?
Well, for a ton of common problems, you don't need to loop over and over again. Turns out there's a really clever strategy called the two-pointer technique that often lets you get the job done in just one pass.
It's this super useful pattern for things like comparing elements, searching for pairs, or even reversing a whole sequence. And doing it in a single pass is huge. It can take what looks like a slow, complicated problem and make it surprisingly fast and simple.
By starting at opposite ends and working toward each other, they can cover the whole area and compare notes way more efficiently than just one detective walking the entire length of the street twice. It's just smarter. So let's see exactly how this works.
We're going to put this to the test with a classic problem you see in coding interviews all the time. Checking if a string is a valid palindrome. Something that reads the same forwards and backward.
So you look at this, and your first thought is probably, no way, that's not a palindrome. Our job is to figure out if it is, but there are a couple of really important rules that change the whole game. So basically, all that stuff, the spaces, the comma, the colon, the capitalization, we just ignore it. None of it matters. And this is exactly where the two-pointer technique absolutely shines. It lets us cut through all that noise and focus only on the characters we actually care about.
Okay, so here it is in motion. We set up 2 pointers, one at the very beginning of the string and one at the very end. First things first, we skip any junk. The left pointer hits a space, move it. The right pointer hits a colon, move it. Once they both land on a letter, we compare them. A and A, they match. Because we ignore case, great. Now, we move both pointers one step inward and do it all over again. We just keep doing this, skipping, comparing, moving inward.
If at any point we find a mismatch, game over. It's not a palindrome. But if our pointers meet in the middle and every single pair is matched up, success, we have a palindrome.
All right, let's do a quick recap and see what we've added to our conceptual coding toolkit today. So let's just boil this down. Linked lists give us that awesome flexibility that arrays just don't have, and the two-pointer technique gives us a super efficient strategy for processing these lists, often in a single go. It's really that combination, the right data structure plus the right strategy, that leads to some seriously elegant code.
At the end of the day, it's all about picking the right tool for the job. You need instant access to items, and the size won't change much? An array is your best bet. You need to constantly add, remove, and reorder things? A linked list is going to be your best friend. And when you need to process that list efficiently, the two-pointer technique is an absolute go-to.
And that's really the core of mastering this stuff. It's not about memorizing code, it's about learning to see the underlying pattern in a problem and then choosing the perfect structure and strategy to solve it elegantly. Thanks for watching.